Hey folks, welcome back to KKR Renewables Metal Recovery Channel. Big shout out to all of our miners and refiners out there making the metals we use every day. Our channel focuses on the recovery of those metals, making sure they get back into the production stream and don't wind up in our landfills. If you like what we do here, please help support the channel and smash that like button, then subscribe and share our videos. In today's video, we'll be working through the entire process to recover gold and then further refine it from 1.83 kilograms of square flat packs. That's approximately 4 pounds of square flat packs that I purchased from eBay. Well, that's enough of the intro, so let's get on that road to recovery. Hey folks, welcome back to KKR Renewables Recovery Channel. I've been shopping again and went out to eBay, found a 1.89 kilogram lot of four-sided, four-legged flat packs, and I thought I was getting a pretty good deal on these. I noticed one thing immediately when I got them. If you recall, I processed 1 kilogram of four-sided flat packs not too long ago. You can find my video on my channel, in which I got back more gold than I had anticipated, which was great. Those 100% of those flat packs were all from CD-ROM boards or something similar, and they were very, very thin. First thing I noticed about these flat packs is they're all very, very thick, and some of them have a lot of weight to them. They've got copper heat spreaders on top of them. We're going to weigh all these up, and then we're going to separate them all out and see how many of each I have. I think maybe these are really skewing my numbers. Let's get a weight on these and see how it goes. So I purchased 1.89 kilograms and I got 1.836 kilograms. I guess I can't really complain about that. That's pretty close. Might just be a variance in the scales accuracies that the gentleman who sold these to me and I use. I figure that's close enough. All right, let's use the more accurate scale here, and let's put, this seems to be the heaviest one that I've found. As I was pouring them out of the bag, I didn't see too many that had heat spreaders really very, very visible in from the tops of them. But let's just go ahead and weigh this one up. 12.8 grams. Tear this and weigh it one more time. 12.89 grams. Another one, 5.5 grams. There are a few very thin ones here that are not the same ones that I got the last time. There may be a few, but they're about the same size. I actually had one of these in the previous lot. I'm gonna weigh that, 2.52 grams. So these thicker ones are approximately twice the weight of these thinner flat packs. A flat pack is any surface mounted device that has legs on the outside, and it gets soldered down to the motherboard or to the circuit board via these legs. This is opposed to electronic components that are what they call through-hole components, where you have legs that go through the circuit board and are soldered either to the top or the bottom of the circuit board, depending upon the depth of the through hole. These all get soldered to the surface, so they're pretty easy to remove, but as a result of most people using a chisel to remove those, you get a lot of the legs as well. So just to reiterate, this is 2.5 grams. This is 5.5 grams. And this heavy one, thank goodness, is not the norm for what's in this batch. It's 12.8 grams. Let's grab a few more others at random. Here's another small one. I recall processing these in the other lot as well, 1.9 grams. Here's a bit larger Xilinx, not sure how to pronounce that. This one's 7.9 grams. So they range anywhere between 12.8 down to 1.9. It looks like most of them are going to fall somewhere in the middle of that based on the way this looks. So I'm probably going to think somewhere to 7 to 8 grams, which is about 3 times as much weight as these. So let's do some math and we'll see if we can come up with a guess as to how much we think we're going to get if this entire batch weighs about 3.5 times more per unit than the other one did. Let's do some math real quick. So here's my real fuzzy math with how much I think I'm going to get from this lot, given that I'm just going to assign roughly 3.5 times the weight in this lot per unit. So the first lot that we ran was 1 kilogram. 3.2 grams is what I got from that lot. That was great. It was fantastic. This particular lot, I've got, I'm going to say, roughly 3.5 times the weight per unit. Per unit. So I'm going to say basically per unit, roughly, it's about 1/3 the gold content by weight. So again, if this weighs about 3.5 times as much as the similar unit from my previous batch, I'm thinking they've all got pretty much the same number of legs, probably the same amount of gold inside them per the number of legs that they've got. If this one weighs 3.5 times the weight of the other packaging, I think I'm going to get 1/3 the amount of gold by weight out of each one of these individual units. So if I say 3.2 grams, roughly 1/3 of that is roughly 1 gram. I got 1.83 kilograms worth of chips right here. 1 times 1.8, not too hard. I think I'm going to get 1.8 grams of gold out of all of this. I did not pay that much for these, so I think that'll be a win when I consider time, propane, gas, the chemicals, the bit of electricity that we'll use. I'll probably break even with what I paid for these if I get 1.8 grams. All right, so we're gonna go ahead and start this probably tomorrow. We're gonna burn these chips and then we're going to begin the regular ashing process that I do, whereby I'll burn them, then we'll do the gravity separation, then we'll do the straining. We'll filter all these legs out. I will run all of these legs through a strainer that'll catch these legs so I don't waste the acids processing base metals. All right, I'm gonna go ahead and separate these out based on thickness and whether or not they have heat spreaders visible to me, just to kind of get an idea to see if this is about right. These two piles here are our flat packs that have heat spreaders in them. It became really apparent as I was picking each one of these up just how much additional weight each one of these has. It was very easy to tell which ones were going to be the ones with the heat spreaders in them. And of course these all seem to fall to the bottom. They're super light and thin. So what we're going to do is I'm going to take the original amount of 1.83. I'm going to subtract out the weight for the heat spreader flat packs. I'm going to subtract out the weight of the super small flat packs, and then I'm going to weigh the remainder and see if maybe my 3.5 times was accurate. All right, so let's go ahead and put this here. We will tare that. All right, so here is my new fuzzy math. So 5.5 grams for each one of these. The other ones that I did previously were about 2.5 grams each. So per unit, I'm getting about half out of these per weight what I was gonna get, or what I got from the 1 kilogram lot that I processed already. So going with that fuzzy math, I got 3.2 grams out of that lot by weight, unit by weight. If it's about half, so I divide by 2, I'm going to get about 1.6 grams for the first kilogram of these I have. Then I have another 492 grams, which is about 500, and it's about half of this. So I took, if I'm going to get 1.6 grams from a kilogram, I'll get half of that from 500 grams. So I'll get 0.8. 1.492 is approximately 1,500 grams. So I'm thinking I'm going to get 1.6 plus 0.8, 2.4 grams. This feels like I'm being generous with myself to get 2.4 grams of gold out of these. So I'm going to say that I'm sticking with my previous number, sort of. I'm going to get somewhere between 1.8 grams and 2.4 grams of gold out of this entire batch. Frankly, I think the weight for the copper heat spreaders and the thin ones are just inconsequential when I look at the number that I have here, the total number that I have here. So that's the way I have to do it. I don't know a better way to figure that out. If anybody has an idea of what would be better, let me know. But again, I'm thinking between 1.8 and 2.4. If I get 2 grams of gold out of this, I will be super happy. That will be a bit of a profit back to me. Not much, but a bit of a profit. And I'm having fun making it, and I got a YouTube video out of it, so hey, it's all great. So, like I said, next steps is, when I get a free moment, I'm gonna burn these. I'll film that and show you that, and then we'll go through the same process that we do before. I do not do the hot sulfuric acid wet ashing method. It's just too dangerous. I don't like messing with sulfuric acid at all. I don't like messing with hot sulfuric acid even less. So you'll see pretty much the same process from me. We're just going to try to continuously refine it, talk through it as we go. So maybe I'll say something, maybe I'll learn something, maybe I'll do some research, and I'll share that with you along the way. Okay, I hope this was some fun math, and let's see how it goes. I just wanted to point out one more thing as I'm packing these up. It dawns on me that in all my research, what I've been told is that mixed IC chips get about 0.6 grams per pound out of them. A pound of these is about half a kilogram. a kilogram is 2.2 pounds. If I do some quick math and I say I've got 1.8 kilograms times 2.2, I've got 3.96 pounds times 0.6, it's 2.376. So that's pretty close to this number. But you got to remember, I got those heat spreaders in there that are weighing 280, 300 kilograms, something like that. So, yeah, I'm feeling pretty confident somewhere in between here. Okay, enough of that. Somebody tell me also, you know, I don't know, do these little legs, are these worth keeping? Do they have any silver in them? And I don't mean the solder balls that are on them. I mean, do the actual legs contain any silver? You might have seen as I was going through here, some of these things, I've got some Intel 386 chips in here. Don't know if they're old enough to have silver in the legs also. I just don't know. So somebody tell me. Thanks. All right, I just can't help myself. I'm going to continue to do a little more experimentation. I'd like to burn 2 of these chips. These are both with the heat spreaders in them. I'd like to see just how much gold's in there. So what I'll do is I'll burn these, and then I'm going to take them to the these to the microscope, and then we're going to sift through them, and I'll show you the results through the microscope lens. Alright, here we have the 2 chips that I just burned. They're cool now, and the heat spreaders are still, everything's still intact. There's still a lot of black carbon on these. Definitely did not burn them completely. It wasn't the intent. All I wanted to do was be able to burn them enough to crush them and get the gold bond wires free. So now I'm going to smash these with the hammer, and the next views you'll see are going to come from the microscope. Okay, I have to say, I got these, I hit these with the hammer like I normally do, and they are quite resilient. I can already see the frame wires here going into the die. Can't wait to get this under the microscope. I burned these again because I just could not crack through the casing on this to get to the gold bond wires. I saw the gold bond wires on the Intel chip, but I did not see the bond wires yet on the Zilnix. I didn't see it here, but I did pull off the top copper heat spreader. There's actually another one under here. This right here that looks like a chip is actually a heat spreader also. So I'll be interested in pulling that out. And the heat spreader on the Intel chip, oh my gosh, it is so heavy. I don't know what this thing is. I guess it's just copper, but it must be really, really thick. It's very heavy. So I thought I'd show you also what I do with these is I just take my hammer, and you can hear everything crunching and grinding up. I don't mash it up too much. I don't get it too broken up at this point because I really enjoy digging through it with the microscope and the tweezers. But this is what I'm doing. Hope there's enough light in here. All right. All right, so this is the piece of the video where I am burning the chips, and then I'm taking the chips and I'm putting them in my rock tumbler so that I can crush up the chips to a fine powder. Alright, I've done almost this entire bucket, so I'm gonna try to refire this, but judging from the weight, this feels like it might be a ceramic chip, and I don't know how hot you have to get ceramic chips to, I don't know how hot you have to get them to the point where they can actually be ashed, but I can't produce that kind of heat. So we're just gonna dump this out. And again, you want to be really careful. You want to do this outside. There's lots of little silica, superfine silica dust in all this stuff. And you either want to be wearing a mask or you want to be doing this outside with a slight breeze, like I've got a really nice breeze today. So let's pull out the balls from here. We'll put the chrome balls back in. I just have these two balls in here so they'll bang against each other, and they will bang against the chips, and they will crush the chips into a really fine powder. Here we have what the chips look like after I burn them. Other folks use grinders. I wish I had a grinder. That would make this process a whole lot faster. But I don't. And I don't want to spend any more money on anything, so I just make the best use of what I've got. So I will have to do another round of this for these last bit of the chips. This is the last load of the 4 pounds of IC chips. These are quad-sided, thick flat packs. I got these off eBay, and I'm doing a little experiment to see how much gold I'm actually going to get out of them. Hey, the dog stopped barking. That's great news. All right, we'll put this away for the next time. Put the lid back on this so the dust doesn't kick up or doesn't spill. All right, we'll see you when that's done. Alright folks, we're going to move on to our next stage where we're going to take the carbon that we have ashed to a gray or a white color. We're going to take them scoop by scoop with our handy little watch glass lid. Put them in here. We'll sift through that with the magnet, pull out anything that's ferrous, and then we will put that into our bucket. This will be the bucket that we'll use to do our gravity separation with next. So we're just going to take it from one spot and put it in here. Alright, let's go ahead and get started. I've got gloves on and I'm putting a mask on because the stuff is going to be dusty and I don't want to be breathing that dust in. We've been blessed with a nice little breeze today, so that is good. Gold will stick to these magnetic parts, so you hear them popping right out of the dust. Sounds like a Geiger counter. Try to get a little better view there. So then what I do is I drop them over here, because they'll pick up some dust with them. You see all that dust that came off with it there? And then I'll go back over and pick these up. And put them in my pan. The thinner you can get this layer of ash, the better. And yes, as you've surmised, this is going to take a while. The 1 kilogram flat pack video that I posted a couple of months ago, I tried to do this with them and I found out that they had very little ferrous material in them whatsoever. I was really amazed. So I'll just sit and shake this up again. When you shake it up, I guess it releases a couple of the, it'll release another layer of ferrous material to be able to access. It needs to be fairly close to the magnet to be able to be picked up. It's really tempting to try to speed the process up, but you really don't want to. You shouldn't be in any kind of a rush for any of these processes. They say every time you transfer this stuff from one container to another, you lose a little bit of gold, and I can totally understand that. It's really difficult to contain this stuff. When I'm done with this process, I will wash that pan out. I will wash off these, and I will wash this pan out into that bucket. You want to be sure to get anywhere where there might be writing, or might be little micro scratches. This gold is super, super fine, and it will cling to any of those spots, which is great when you are out in the field trying to catch pan gold, sluice gold. Not so great when you're at home and you don't want to lose gold to the outdoor sprayer. Alright, we're going to call that done. Next step, gravity separation from this bucket onto my catch pan. I've got a primary and a secondary catch. I'll show you that setup in just a minute. Alright folks, here's my setup for my gravity separation. I've got my clean water that I'm going to be putting in the bucket of ash. I've got my glass stir rod. Got to be careful with that, you just got to stir gently. I've got some rinse aid, some jet jar rinse aid that I use. And then I've got my primary and my secondary catch pan. I pour the ashes out of the white bucket and into the glass jar. If anything pours over from the white bucket into the glass jar that I want to keep, it'll collect at the bottom of the glass jar. The jar is tall and narrow, and a lot of turbulence would be needed to raise whatever that would be up and over and into the secondary catch. When the secondary catch fills to approximately where this line is, I'll just simply dump it. It's just burned carbon. There's nothing toxic, there's nothing that is harmful in any of this. So we can now feel safe just dumping it. Alright, let's get started. Watch what happens when the jet dry touches the top of the water. See that breaking up? This is awfully thick. It usually just disperses completely. So I'll put a little bit more jet dry in there. to break up those bubbles. This amount of oils and whatnot that is inside the thicker flat packs. I mean, this is crazy. This is a lot. But I'll slowly pour this off. It'll raise to the top, and then I'll get rid of it. At this point, we want to keep everything in there we possibly can. We're going to let that settle, and then we're going to slowly pour off into our primary catch. I guess the idea is that all your gold's in the bottom of the bucket, and you're just trying to break up this top just to make sure that there's nothing floating up here. Let's pour into the catch again. I'll see if I can pour at a better angle for you. The more you ash your carbon, the easier this part is. See how that just completely spread all the oils and whatnot apart as it removed the water tension? That's the benefit of using the jet dry or rinse aid. Some people like to use just plain Dawn. That's fine too. I find that I'm a little turbulent with my pores, and when I use dishwashing detergent, it tends to cause the water to bubble up, which I don't want to do. I'm going to pour this off, and then I'm going to get right back to it. Alright, let's take it to a beaker and see what we're dealing with. Alright folks, I have completed doing the gravity separation, and I dried everything out on my hot plate so that I could get a really good look at what was inside the mix. And if you see here, there's still somehow some metal got through that was pretty big. I'm not sure how that was. Maybe that was from the very first bit of material that I processed. Maybe I didn't filter it well enough or sift it well enough. So I'm going to re-sift this again and try to pull out some of those larger pieces of metal so I don't need quite as much acid or take quite as much time doing my acid baths as it would otherwise. So let's go ahead and get that done. I'm going to try to get that done before the sun comes over here and shades this area too much. Again, I'm going to be using my two classifiers. This will catch the larger heat sinks, and this will catch the lead legs that I can see in here. Let's go ahead and get that done. Oh my. have quite a bit of metal still in there, and more falling out as I sift. Well, as you can see, it took me a little while to get things going, and I'm in the shade again, but hopefully that's okay. Hopefully you can still see that. Look at all that metal. All that was still in after the gravity separation and after the initial sifting. We're going to put this to the side. I guess we'll leave that much metal still in there so that we can not have to sift this thing many more times. I'm going to go ahead and rinse out our bucket because there could be gold bond wires stuck inside any of those cracks. Next thing we're going to do is we're going to drain that water out. We're going to let that settle. We're going to drain that water out, and then we're going to put it on the heat with an air bubbler and some hydrochloric acid for a couple of days. Alright folks, I've got some water. I've got about 300 milliliters worth of sediment and water in here. I'm going to add my bubbler. You can see it's just pumping in regular old air from an aquarium pump. I'm going to add a stir bar just in case I can get some movement in there as well, just to make sure the acid contacts as much metal as possible. I'm going to put 500 milliliters of muriatic acid. Let's go ahead and add that in. Alright, and we're going to go ahead and just cover this. We're going to cover this up and let this boil away on heat for a couple of days. I could use nitric acid to get this done a lot quicker, but I really don't want to produce those deadly fumes, and it's really expensive and hard for me to get nitric acid, so not gonna do that. Alright, we'll be back in a couple days. Here we have our cupric chloride. This has been on the bubbler, the stirring, and the heat for about a week now. The stirring I don't think has been doing a whole lot of good because the substrate is just so thick the stir bar can't really spin in there, but it's causing a vibration, and that's good enough for me, I think. So what we'll do now is we'll turn the heat off, we'll turn the stir bar off, we'll pull the bubbler out, and we'll let this all settle and then filter that out. I'll be right back when we're ready for that. Okay, this has had a good little while to cool off now. It is room temperature. The hydrochloric acid won't be fuming anymore at this temperature, so we're good there. This is very low fuming hydrochloric acid anyway. The green color, I think, tells you that it's the low fuming. Alright. I've got my Stony Lab funnel. I've got a Stony Lab filter in. I'm going to pre-wet that filter. It's just regular tap water. We don't need to use anything special here because this is hydrochloric acid. Okay, I can't really tell how well the light's doing because the sun's coming from this direction now, so I hope this is okay. But you can still see the color of green that we're dealing with here. I'm going to turn the pump on. let's go ahead and start filtering this out. You know, I thought this would filter clear for some reason. I guess the amount of super fine dust and carbon that's still in here is just really hard to settle down. I noticed there was maybe a gap about this much here between the darker color and the green color, so I think that's what it is. I just didn't give it a whole day or two to settle. Okay, as you can tell, this is going to take a while to filter, so I'll be back when this is done. So I don't know if you can see this or not, but there's a light colored band at the very top of this. I often wonder what that is. It started off being blue, but now it's got kind of greenish again. I think this is copper chloride 1 with adding the water to this and really diluting the copper 2 chloride, and it's slowly mixing in, becoming copper 2 chloride again. So I think that's what it is. If anybody knows that that's the fact, please let me know. Alright, here we are. We're not done filtering yet, but I did add additional water to this just to kind of break up the bottom. When you heat it for this long, the bottom gets kind of chunky. So I wanted to go ahead and break that up so I could do this. Can you see that by any chance? I will take a better picture, but there's a bunch of gold down here that you can see really clearly. I'm going to go ahead and keep filtering this, but I did want to go ahead and get a Stannous test on this. So my battery just died, and I just go pop in a spare real quick. So I'm hoping I'm still at the same angle. Let's go ahead and do a Stannous chloride test on this. Anytime that you use acids on your mixtures here, your substrates, I think you need to do a Stannous chloride test. Reason being is we're not in a super sensitive lab environment, and everything isn't always perfect, so you want to make sure that you always test to ensure that you're not losing gold. Let's see if you can see that. Look at that. See that dark stain? There's gold in there. Now, what am I going to do with that? I don't know. I'm going to have to go read on that. This is the first time ever for me that has ever happened. Maybe I had my heat a little too high? Not sure exactly. But okay, there's gold in there. That's good to know. While I'm doing research on this, I will go ahead and continue to filter this. Alright, I've decided what I'm going to do with this material. It seems to have some sort of precious metals in it, but not really a whole lot. Here's the results of my Stannous chloride test. I see a small outline of dark around where the test was, so I'm thinking this is just trace amounts of something. I'm not sure if it's gold or not. I did some more research, and hydrochloric acid plus an air bubbler is not supposed to dissolve gold, so maybe it's a different precious metal. So what I'm going to do is I've labeled myself a jug here with exactly what it is. This is an old muriatic acid jug, and it's completely empty. So what I'm going to do is I'm going to pour this off, and I'm going to keep filtering this. As you can see, it's pretty much nothing but water now. Once I'm done filtering that, then I'm going to add hydrochloric acid and a couple drops of nitric acid to create aqua regia. We're going to dissolve that gold in there, then filter that out. Hopefully that'll be today. I'm going to pour some additional hydrochloric acid in here to rinse it out with some HCl. Maybe iron chloride in there. So rinsing it out with HCl will not dilute the solution any further, and I can use this again on my next pin dissolve. I'm using the same filter. It's very clogged, and that's okay. This is all just pretty much water in here at this point. Alright, while this is filtering out, I'm going to go ahead and add hydrochloric acid here and get the nitric acid ready, and we'll go ahead and start our nitric acid boil. Alright, we're going to put about 400 milliliters of hydrochloric acid, maybe 300 milliliters. Let's go ahead and turn the heat on here. We'll go ahead and get that started. We want to heat our aqua regia up to be about 90 degrees Celsius. So we will go ahead and heat this up to that point before we add the nitric acid. I would really like to have all of this off the side and flat on the bottom to give it as much surface contact with the acid as possible. We'll add our makeshift watch glass. It's not really a watch glass, I can't watch through it, but what it will do is it'll keep the fumes from the hot hydrochloric acid from escaping. Alright, we're going to let this continue to filter, and then we'll bring this up to temperature. We'll be back when we're ready to add the nitric acid. Alright folks, I've had this on another hydrochloric acid boil for about 3 days. What I'm trying to do is get the gold as clean as possible and get as much copper out of the solution as I possibly can. That'll really help in the final refining process and make my first gold drop pretty clean. I'm gonna turn off the heat, turn off the stirring, turn off the bubbler, give myself a Stannous chloride test to make sure that there's no precious metals in solution, and then we'll filter it into our filter here. I've got my Stony Labs filter, we'll put that in. I've got my Stony Labs Buckner funnel, and I'll turn the suction on because it's pretty loud. I'll turn that on when we're ready to start filtering. Alright, let's give this a test. I'm about out of Stannous chloride. So I'm making myself a fresh batch. Alright. I see no precious metals in that at all. That little dark line, if you can see that, that little kind of dark strip there is from the discoloration from the copper chloride too. And because my Stannous chloride is a little old, it's several months old, I'm going to go ahead and take some from my fresh batch. And just do another test. And there's nothing. So I'm gonna let that, gonna put that in with my other papers, and time to start filtering. So I'm gonna turn the suction on, so you'll hear some background noise there. All right, I almost forgot to start recording. Alright, I'm going to get my filtration paper, because I forgot to do that, and we'll now filter this. Alright, the sun's going down here, so I apologize for the lighting, but I hope that we can still see this okay. I'm going to go ahead and put this first bunch of mostly water. I'm going to go ahead and pour this right in the to evaporate bucket here. You can see there's a bunch of sediment in the bottom of this filter. It's causing it to filter really slowly. But I'm going to do one more. Get all this sediment washed off really well from the acids. Almost forgot to put this back on. I want to get this really washed off really well. Alright, when this is done filtering, I'll pour the remainder of this beaker in there, and then we'll take it inside and we'll try to pan it out. Alright folks, here we are inside the house. I'm at the workbench, and I've got my beaker of gold bond wires. I'll put them in my pan here, and I will attempt to pan them into a larger pan. I got these for my birthday 2 years ago and just haven't done anything with them yet, so that's not a bad thing to do, I guess. I'm going to pretend like I know what I'm doing, but I really don't. So let's go ahead and mix our water up in here. And pour everything out into our pan. Wow, I can see all the gold bond wires in there already. I'm going to get the sprayer, so I think I'll do a better job getting those wires out. Let's go ahead and take this out. And let's spray our gold bond wires out of here. They are super heavy and just don't seem to want to come out of the beaker. I see there's still some in here. Why don't they want to come out? This already makes me worried I'm going to lose some. Gosh, they just don't want to come out. So these things are microscopic, so I can't even really see them unless they're all clumped together. And it looks like we've got a bunch of them in the pan already, up on the wall. I'm sure everybody who's really skilled at this is just having a good laugh right now, but man, I really don't know what I'm doing. So maybe I'll learn one day. Hopefully I will. All right, so let's see if we can. I think I want to use the smaller gradient whiffles here. So I'm gonna pour this water out. If the if this experience with the beaker is any indication, I'm gonna have a hard time getting the bond wires out of this thing with all of its little nooks and crannies in it. Look at all of that. There's a whole lot of what looks like maybe silicon dye pieces. So I'm gonna shake all the gold down. Still, my ultimate goal for this is I want to get rid of as much of this of the silicon that I can, so I can use as little acid as I possibly can when I go to actually refine this gold and do a normal gold drop with my sodium metabisulfite. I'm going to add some more water to my catch pan here. I've just seen people do this on YouTube a lot, you know, whether it's, you know, Dan Hurd or Jeff, I'm sorry, I don't know your last name, or maybe even, you know, Mount Baker Mining and Metals. You know, I've seen these guys all do some panning. They all just go real slow with it and just let the gold build up where it will. And everything else just kind of runs off the top. I'm still keeping all that because I'm sure I don't know what I'm doing. This is my first time. I'm sure I'm losing gold. Look at all that. That is a lot of gold. Well, not a lot. I'm thinking I've got maybe 1.8 grams is what I had said. But I see gold floating on top of the water. I see the little gold bond wires floating on top of the water. Let me get some jet dry and see if that takes care of that. Alright, can you see all that gold floating on top of the water there? Let's see if this breaks the surface tension. Well, it's certainly part of the gold. I don't know if any of it fell down into the water or not. Or fell down to the bottom of the pan. Alright, I am going to go with I do not know what I'm doing, and I should probably just go back to what I think I know. So I can see that the silicon dyes are all clumping in the middle there, but there's a lot of gold bond wire there as well. So, all right, I'm going to call this quits. Maybe somebody can comment and let me know what I should have been doing instead of doing what you saw me do. And I'm going to go ahead and put this into a 1 liter beaker, maybe a smaller one if I can find a smaller one, and we'll go ahead and hit this with aqua regia and we'll get that gold dissolved. Okay, this is a fun little experiment, but I'm going to stop it here. All right, so here we are. I've got my beaker. I've got a 500 milliliter beaker, and I've got all of this. I'm going to go ahead and try to just pour all of this in the beaker. Probably not going to be the best view, but I'm going to spray all this into the beaker. Beautiful. Spraying real gently. Yep, that's difficult to get the gold out of there. Maybe I should have dried it first, I don't know. Difficult for me anyway, so hey, open myself up. Some of you guys who know what you're doing, give me some pointers. Even if it's to stay in my lane. Okay, I think I got everything out of there now. I'm gonna take whatever might still be in this beaker, if there is anything at all. Okay, I'll take this. I'll tell you what, that gold certainly is heavier than the whatever carbon is left over, and also the silica dyes. I'm going to take another picture of the bottom of this beaker, and I'll show you that right now. I'm going to keep pouring this off. All right, I'm going to pour all the rest of this water off. All right, I'm going to go back outside and work with the muriatic acid and nitric acid to make my aqua regia. You can actually see it right there. Slow to move. How about that? Okay. All right, here we are with our gold back in our 500 milliliter beaker. We're going to go ahead and pour in about 150 milliliters of hydrochloric acid. I also don't know how to compute how much I actually need, so I'm just going to go with kind of what feels right. Probably don't need that much. I'm going to turn the heat on, cover it with our watch glass, and add a thermometer. As we've said before, I want to get this to where it's around 90 degrees Celsius. All right, we'll be back when that's at 90 degrees. All right, we are at, I don't know if you can see that or not, but we're at 85 degrees Celsius. That's a good temperature. Back this off just a little bit. I don't want it to boil. We're going to go ahead and incrementally add our nitric acid. I feel like this should be plenty. This is 2.5 milliliters of nitric acid. Let's go ahead and see how that reacts. You can see the reaction over there, looking really good so far. Alright, I see no more reaction. Oof, that is really hot. We'll go ahead and do a Stannous test. I feel like I know how this is going to turn out, but I really want to show you guys what this looks like. So here's my gold test and my drop of Stannous. It's turning instantly dark purple, black in color. That is a positive test for the presence of gold. Alright. Put that right there. Okay, we're going to turn this off and let this cool down. We're going to make sure we don't have any excess nitric acid. And we do. Look at that. We just want to add super small increments at a time. So we want to make sure that we don't put too much sodium metabisulfite in there, because we'll wind up with a runaway reaction, and we do not want that. So we want to mix all this up really, really well. Yeah, I put way too much nitric acid in there. Alright, we're going to give it just a little bit more. And my gimbal just died, so alright, we're going to let that cool down, and we're going to double the water, and then we're going to filter it. Alright, I have no idea what has just happened. I put tap water in there. I figured I could do that because I had hydrochloric acid and nitric acid in there. I figured it was safe to put something with regular chlorine. I didn't think I needed special water. So now I'm going to do another Stannous test, because that sure looks odd. Somehow, my tap water performed a gold drop. No idea how that happened. Maybe I put too much sodium metabisulfite in it, raised the pH too much. Alright, I'm not going to touch this anymore tonight. We're going to let it be until I can figure out what's going on. Alright folks, it's been a day. I didn't know what was going on yesterday, so I just decided to leave everything alone and come back and check it out. Well, as I thought about it, I realized what I had done. I think I was somewhat out of sorts because of the panning situation. So I didn't even realize that what I'd actually done is I grabbed the sodium metabisulfite rather than the sulfamic acid. And I was adding this as if I was adding sulfamic acid. I wasn't getting the results that I expected, and I just kept adding and adding and adding. So now I think I've over added sodium metabisulfite. Now I did double my water, which is good, but I read online that there might be some detriment to adding sodium metabisulfite before you hydrate with double water. It can create a complex that is not good. The way around that is to evaporate it down, heat it up with a flame to about 800 degrees Celsius, and that way you'll break the chemical chains that are created between the gold and the metabisulfite. I'm really hoping I didn't get to that point, and I'm really hoping that all I really did was perform a gold drop and denox with a lot of sodium metabisulfite. So I'm going to do another Stannous chloride test to make sure there's nothing in solution here. Then I'm going to pour this off into my evaporation bucket just in case that research was correct. And then we're just going to start over with aqua regia and try it again. Let's see how it goes. All right, I don't see any gold in there. So let's put this down and let's pour this off into our to evaporate bucket. That is sure behaving like gold. Let's hope it is. So what I'm going to do is I'm going to pour this off, and then I'm going to add some really hot water to it, wash all this out, and I'm going to start over with aqua regia. So I'm going to spray this down a little bit. There's some stuff floating on the top that I would like to sink before I pour this out. All right, let me get my hot water. Give that a minute to settle. Actually, doesn't even need a minute to settle. It settled very quickly. I think it's pretty interesting that you can see the chip and the die pieces are lighter than the gold because the gold's at the bottom of the chip and die pieces. Alright, one last hot water wash, and then we will start over with the aqua regia. Make that a pretty significant amount of water. We're going to let that settle a little bit longer. Now I understand if what I have has been chemically bonded with the sodium metabisulfite, I will not be able to chemically break that bond, which means when I add my aqua regia, nothing will boil up. So let's hope that doesn't happen. Everything was going so beautifully until I messed up. That's usually the way it goes, right? So let's start this over. I'm going to go ahead and add 150 milliliters. Let's put some heat on this. I'm going to put my watch glass back on. I'm going to get my thermometer and put it in there. Alright, we're going to let that do its thing. It's going to heat up, and then we are going to add a little bit of nitric. I'm only going to do 1 milliliter this time and see if that's enough. I do not want to go with too much nitric. Alright, I see we're about 85 degrees. That's getting pretty close to where we want to go, where we want to be. Crank that down just a tad. So that is 1.5. We're going to do about 1 milliliter. Let's hope we start seeing a reaction soon. Excellent. Alright, I don't see any more reaction, and adding additional nitric did not cause any additional reaction. Let's go ahead and do a Stannous test. We pretty much know how it's going to come out, but let's do a test anyway. And you see that instantly black. So there is our positive Stannous test. That's good. Alright, now you need to add the sulfamic acid while it's hot. And this time we actually have sulfamic acid. That's indicating that there is excess nitric. Smaller reaction is a good sign. Little to no reaction is even a better sign. Give this a stir. Let's add a little more sulfamic. And practically no reaction. So that's good. We're done with this sulfamic. Let's turn the heat off. Cover this back up because I don't like it fuming like that. We're going to let that cool down and then we're going to filter it. Alright, let's go ahead and add some ice cubes to help cool this down. And that will also effectively work towards doubling our water volume. Hey, I realized I forgot to turn my light on. So you can see that we've added ice cubes. They're still floating in there. Temperature is about 30 degrees Celsius. We'll just give that a quick stir. And if we look, our water level is right almost at 300. When those ice cubes melt, we might just get down to 300 even, but that's great. We're not going to add any more water. Next step, we're going to do our filtration. And I'll show you that when we're ready. Let's go ahead and start our filtration. I just rearranged my camera better. All right. Go ahead and pre-wet the filter. And we'll go ahead. The solution's already very clear. Clear solution is what you want to look for because cloudiness in your solution means impurities. We want to go ahead and get all that up too. Sorry, I'm blocking your view. I don't have a choice. All right. I'm going to go wash this beaker out because I'll do my gold drop in this beaker. Be right back. Okay, let's give this a spray down. We want to make sure that we've got all the chloride acid, which is what aqua regia is. We want to make sure we get all that washed through the filter. Alright, that's draining clear. So we will take this and put it to the side. We'll pour our chloride acid into our 500 milliliter beaker. You can see how beautiful and clear it is. And if I can stay out of your way, I will. I'm just going to rinse this out. All right. Going to go ahead and get my sodium metabisulfite ready. I'm going to drop it in dry this time. I do like to drop it in wet, as in I like to dissolve it in water first a lot, but I've already doubled my water, so I don't want to do that this time. Let's go ahead and get a little bit of a vortex going. And we're looking for the white bubbles, which I don't see any yet. There we go. There's our classic color change. We're going to give that a little stir. Looks like we might have a little more at the top here. You see that banding right there? All right, we're gonna let that settle down. We're going to put our watch glass on and just going to give this a little bit of warmth, not much. We are going to give this one more Stannous chloride test to make sure we got everything. I use chopsticks from my dinner. I just use I use a knife and I cut a slit in here, and it makes the perfect holder for my test strips. Alright, don't see anything in there. It oftentimes looks like there's a little darker band, but I really think that's just from where the two different liquids mixed. So, but yeah, I'm going to call that nothing. Maybe a minute something, actually. But it's so minute, I'm going to let that go to the stock pot. Okay, we're going to let that go on, and I'm going to let my memory card just run out here and see how much we can record. Okay, we've now let this settle overnight, so now what we're going to do is we're going to pour this off into our gold wash bottle. Hopefully you can see that the gold's clumping together really, really nicely. That's what you want to see for a really clean gold drop. I can also see, with a light background, there's gold all in the inside of this beaker. So I'll get that off with aqua regia and filter that out as well. So there's our gold. Okay, it's going to take a little while to filter all this off, so I'll get to doing that, and then we'll do our hot water washes. Be back when we're ready for the hot water washes. Alright, we're almost ready to start the water washes. Just wanted to show you that. Hopefully you can see that. That is some beautiful gold. I did a good job getting all the base metals out with those hydrochloric acid boils. The whole AP solution method that I used with a bubbler worked like a champ. Alright, let's get some hot water in there. See how that gold's just sloshing around in there, all moving around as one clump? That's what you want to see. So even if you swish it around, you wind up with really nice looking gold in there. Just wanted to spray down some of those floaties. Hope you can see that. There's the gold that's all in the rim of this. I'm gonna need to, yeah. I'm gonna need to get that out with aqua regia. Let's do another hot water wash. I have to admit, this looks so good to me that I don't think I really even need to do any hydrochloric acid boils. I'm just going to go ahead and, more than likely, I'm going to go ahead and take it straight to the crucible. This little filter I have in here is getting clogged, so I'm just going to take a little bit longer to filter this out. As soon as we're done here, I'm going to change these filters, and I'm going to go ahead and take that straight to the crucible in a clean filter. Alright, I just realized that my GoPro really was not recording anything, so I'm not sure what I have and what I don't have. But I do want to show you what the clean filter looks like once all the gold is in it. That's probably 3/4 of a gram. Alright, let's take it to the crucible.